Good morning. My name's Michael. I run product at Beryl. It's a great pleasure to be here. I'm actually the second blonde-haired, glasses-wearing speaker of the day. Not too many of those to come. Do we have any screen notes by any chance? Otherwise, this is going to get interesting. If we can stick some notes up, that would be great. But let me push forward. I want to tell you a story today about how Beryl is building better bike share for cities around the world. But actually, I just want to kind of step back a little bit and tell you more our experience of bringing hardware and software closer together. It's also really exciting today because I think Beryl is the first hardware company to ever have spoken at a Jam conference, which is really awesome. So definitely everything I'm going to be speaking about today is from the perspective of a hardware company and a hardware team, how you build hardware products, but our experience of bringing a digital product team into that as well. Beryl, and some of you might know us actually as Blaze. We rebranded not too long ago. Beryl was started by our founder, Emily, back in about 2012, I think, with a very, very clear mission in mind, and that was to make it safer for people cycling around cities. She had one particular problem that she wanted to tackle, which was reducing incidents of cyclists getting caught in the blind spot. An incredible 79% of cycling accidents that involve a cyclist, obviously, and a car happen when the cyclist is actually just moving straight ahead. So a really big opportunity, a really big problem to solve. Emily literally thought, wouldn't it be great if I can have a virtual me cycling 10 meters ahead of me, and therefore that will kind of announce my presence to other road users. And so that led to the creation of the laser light. The laser light is a bike light which uses a laser to project the image of a bike about 6 to 10 meters onto the road ahead of you, and therefore alerts other road users to the fact that you're there. We found that this actually increases the kind of visibility of a cyclist by about 30% when they're cycling around. So definitely tackles this kind of mission of making it safer to cycle around cities. If you don't own one of our bike lights, then you might actually have seen our technology on one of the 12,000 Santander bikes across London, and many other bike share schemes around the world. It was actually our work on this bike share schemes and all the other bike share schemes around the world that, as a business, got us thinking more about the way that cities are changing, so the future of cities, and especially the changing ways in which people are moving around those cities. So bike share obviously plays a big role in that. We were kind of right stuck in the middle of it. And so we were suddenly thinking about, well, maybe our mission is no longer about just making it safer for cyclists, but actually how do we, no longer just about making it safer for cyclists, but actually expanding our mission to make cities better places to live by getting more people on bikes. So there we are. That might seem like quite a big challenge. How are we going to make cities better places by getting more people on bikes? Well, ultimately, we're going to do that by delivering the world's best bike share scheme. But all of a sudden, that seems like quite a big challenge for a small hardware company to kind of go out there into the world and say, well, all of a sudden, we're going to deliver bike share in general. Bike share involves much more than just putting the kind of technology onto the bike itself, but we were suddenly faced with this idea that we would create kind of the back-end infrastructure to start communicating with bikes, pulling data from them, the mobile apps that a user might use to kind of engage with a bike share scheme, unlock bikes, see where bikes are, all that sort of stuff. And then even the tooling and reporting that kind of sits in the background that really powers the operations of a successful bike share scheme. Quite a big challenge for, like I said, a small company of 10 at the time who were excellent at building hardware products, but had no experience whatsoever in building digital products. That was actually the point at which I joined the company just over a year ago to kind of lead that charge in bringing digital into Beryl as a whole. But that immediately struck me as having kind of two kind of challenges. The first one was that hardware clearly works in a very, very different way to building digital products. The way that you go about building hardware products completely different to the way that you build digital products. So it kind of struck me that you can't really just bring another team, like grow a completely separate team into that business. So all of a sudden, that got us thinking as a business about how, as we bring digital into the fold, do we really get it to operate as one cohesive product team, not two separate product teams. So I thought I'll just kind of start by talking about actually the differences between these two teams, how these two teams work. Some of this might be obvious. It's a little bit high level and sometimes simplified, but hopefully gives you an idea as to why I'm saying these two teams are different, and then why we care about bringing them together. So the first point is really about process. My background is entirely digital. I've spent my career so far building digital products. I come from a world that I'm sure many of you, in fact, most people in this room are completely familiar with, this world of agile, sprints, MVPs, lean methodologies, all of this sort of stuff. Something that is completely alien to most hardware teams. A world that is very, very much about waterfall still. If you work with a hardware team, the idea of kind of seeing lots and lots of Gantt charts and big project kind of diagrams is not at all unusual, something that certainly I had a kind of gut reaction to run away screaming from. The second point being to do with dependencies. When you're building digital products, you can actually get away with having very few external dependencies, especially ones that you have to manage a relationship with. This kind of stereotypical startup story of you can kind of be in your bedroom or your garage and write some code and then push that code and push that product out to the world, whilst maybe not entirely true for the majority of companies that are formed, is possible. Hardware, it's much, much more difficult. You have a huge number of external dependencies from kind of your manufacturing partners through to assembly partners, logistics. You've got, if you're making PCBs, you've suddenly got the kind of the component providers. So you might have hundreds of components that all need to end up on a PCB. You've got to manage relationships with all of those suppliers. You've then got something physical that needs to come off the production line and end up in retail, end up in the hands of users, end up on the streets. So huge number of dependencies, huge number of third parties that make all of that happen. So that then brings me on to kind of speed, because again, when you've got software, fewer dependencies, you're able to move much, much faster. You can go through kind of a lot of iteration cycles. This idea of prototyping, kind of testing very quickly is much more common to kind of us in the world we come from. In hardware, even if you have a desire to do that, it suddenly becomes much, much harder to do that. You're measuring iteration cycles in months, not necessarily days or weeks as you might do in the digital side. And ultimately, that really then drives into cost. Software development, digital development, you can have much, much lower kind of upfront costs around building that product. Again, that idea that you can kind of write some code, put together a kind of small product, push it out there. If you want to introduce new features, again, your cost is really just the people that are involved. And then as the business grows, you do kind of have costs around cloud computing, all that sort of stuff. But hardware, you can have astronomical costs long before you've ever put product into people's hands. You have pretty high costs of prototyping. It's kind of unusual because if you want to get a small number of prototypes made, you can end up spending, say your kind of projected cost for a device is going to be £10 a device. You can end up spending £1,000 trying to make that one prototype, which is enormous. But even then, once you're kind of sure on what you're going to build and you go through to the manufacturing side, you can be faced with, if, for example, you've got plastic housing around your product, you can be faced with spending tens of thousands, if not hundreds of thousands of pounds on tooling to start the manufacturing process. So enormous costs, potentially, before you've even started shipping product to your customers. The next point is this idea of embracing failure, I guess. So kind of similar to Tom's talk, actually, the idea that you can put stuff out into the wild that is not necessarily perfect, that is not the complete vision of something that you want to deliver to your users, is more normal to us, especially in very, very early stage digital products. You know you're going to put something out there that might have bugs, that you're going to kind of build new features into. We kind of use technical debt to our advantage. Very different mindset when you're building hardware products, because all of a sudden you're faced with the idea that you've got to put something onto the street that works. You can't, it's very, very difficult to then take something that is already on street in the hands of users and go about changing that. You can do things like firmware updates, potentially, if you've got connectivity, or through USB, that sort of stuff. But especially if you need to suddenly change the actual components, if you need to change the way the PCB works, nigh on impossible. You can only really do that through product recalls, which are very, very difficult, very expensive for you. So you kind of get into this mindset of, can we launch something that's faultless and kind of really absolutely has to work in the way we need it to? And that's especially difficult if you're working on something that's really, really critical to the lives of people as well. And then the next point is similar to the speed one, but it's to do with kind of cycles within your product. So maybe once you've got product out there, again, in the digital side, we're kind of used to this idea that we can then incrementally improve our product, whether you've got continuous delivery, whether you're doing some testing, and then kind of putting new features into that. That's kind of, again, a world we're used to, and that continuous evolution of a product. With hardware, much, much harder. You can actually, and it is kind of normal once you've started manufacturing a product, to make small tweaks to that product. You might swap out components. You might realize there's a problem with the PCB layout, all that sort of stuff. And you can change that. You can kind of feed that into your manufacturing process. But it takes time. It really, really does take time. Again, you're talking about months, and that can really slow you down. And the other interesting and difficult kind of side effect from that is if you start to change that process, all of a sudden you have a mixture of different devices out in the field. You'll have some devices that work one way or are designed one way, and then some devices that are a slightly different version. And that can pose really interesting challenges. So if these two kind of teams work so differently, and actually what's interesting, I kind of thought, what I've just described in terms of how hardware works, you could actually have said about the way that a lot of companies build software actually not that long ago. And probably still true of some like terrifyingly awful companies that still build software in that way. But the idea that you could kind of put together a software project that you kind of say, right, this is what we're aiming for, this is exactly what the product does, and then map it out for 2 years and have your nice Gantt chart, and that's how we build products. I don't think anyone in this room is interested in doing that on the digital side. But certainly that's where software came from. But if these two teams work in such different ways a lot of the time, why do we care about trying to bring them together? Like, shouldn't we just like live and let be, like have these two teams working in their own ways? It kind of falls down to one point. Ultimately, we're building the same product. Like, as a team, we're all working on the same thing. We're trying to deliver the same service. We're trying to deliver the same value to our customers. And so the idea that you might have two completely separate teams that are ultimately working on the same thing doesn't really make sense. The other point that kind of struck me is if we start to bring digital into the kind of predominantly hardware business and keep that team separate, as the company's growing, that's just bound to harm the culture of the business. So that is also something that we kind of wanted to avoid doing. So there we are. We were a hardware company that was suddenly trying to think about how we bring hardware and software development teams closer together. The best way for me to do this is talk through a couple of examples of things that we did and kind of what went well for us and the learnings on either side. The first one is using roadmap to align hardware and software. Sounds really obvious and simple, right? But what we did here is actually form a roadmap of questions. Make sure that we don't confuse that with our development backlog. Like, your development backlog is not your roadmap. Form a roadmap entirely made of questions that we need to answer. The questions, and that's interesting and really useful from a hardware perspective, as well as a digital perspective, because hardware, you can never get around this kind of requirement that at some point you have to lock down your feature set. Like, you have to be able to describe exactly what your hardware is going to do, how it's going to work, and kind of start getting ready to push that off to manufacture. So at some point, you have to get to that point where you can kind of draw a line in the sand, even if the digital side continues working on various different options. So we used a roadmap of questions to help us get to that point. It's easy as a hardware team to become paralyzed by indecisiveness if you've kind of got like a whole range of different ways that you could move ahead. So why a roadmap of questions? This is actually a snapshot of our roadmap at one point. Why a range of questions? Well, the questions kind of really help you step back. They make you think about why you're doing something. We found that from the answers to those questions, we would often be able to derive objectives, which is kind of the what you're going to do. And then that development backlog becomes the how you're going to do that. So let me talk you through an example of how you can go about forming this kind of roadmap of questions and an exercise that we went through as a team. It's really obvious, like as a team, as an entire team, not just product team, like as an entire business if you can, like sit down and think about all of the questions that you as individuals have, all the questions that you want to answer to help you move forward as a team. What do you think is kind of holding you back? What are the big unknowns? Next, really simple, just try and prioritize those really basically. We use this kind of simple scale of what's the impact do we think of answering this question on our ability as a team to move forward? And then how unknown is the answer to this question as well? So roughly how difficult do we think it's going to be to answer this question? So there we are. You then got your kind of questions roughly laid out in this sort of order. And you can then start to prioritize them. This is by no means a science, but it gives you a rough kind of way of being able to prioritize those. You can see in the top right-hand corner, you've suddenly got all of your really high priority questions. These are the ones that are going to have, as a team, you think are going to have a big impact on your ability to move forward as a team. They're the difficult ones to answer as well, so you shouldn't just necessarily kind of sit back and think it'll sort itself out. They're the ones they're the really meaty ones. So these ones are suddenly quite high priority. Opposite that, still high impact, but much easier to answer. You've kind of got your low-hanging fruit. They're the ones that are maybe really tempting to work towards and kind of tackle those first because they're going to be easier, they're high impact. But that generally means that as a team, you probably already know the answer. You probably know why you've even bothered asking that question, the impact it's going to have on your team. So don't necessarily just focus on those ones because they're low-hanging fruit. Try and figure out how they kind of more strategically fit into what you're trying to do as a business. You've then got the further down the line questions. So these are ones that are low impact, easy to answer. They don't necessarily kind of need to fit into what you're doing right now. They'll come, like try and plot them out somewhere in this roadmap. You'll have seen on the kind of previous slide, we just had short, near, and long term. These would probably fit towards the bottom of the near, maybe in the long term kind of column of questions that we'll get around to. And then at the bottom, you've got the very low priority ones. So I would kind of challenge you as a team, if you end up with questions in this spot, maybe don't assume that you need to answer those questions at some point. Probably dig a bit more into why you've felt the need to ask those questions in the first place. If you've got questions that are actually very low impact and really, really difficult to solve, then why do you think that question matters? So maybe as a team, step back and kind of really drill into those questions, and you might find that they kind of break apart, and actually those broken apart questions then fit somewhere else onto that grid. So pulling it back into hardware and why this is useful for aligning hardware and software teams. Like I said, hardware has that requirement that you have to lock down the feature set at some point. You have to be able to kind of design something that is going to go through to manufacture. And because we're delivering the same, like we're delivering a service to our users, in this case like bike share, that has a strong digital component. The hardware is very highly coupled to the service that we deliver to our users. And so you want to go and pick out the questions that have high impact that you think are going to directly impact the design of your hardware. And these suddenly become questions that you really have to prioritize because you know you need to answer these questions before you get to the point where you have to start sending kind of product off for manufacture. And this can be months in advance. So this can be, you have to kind of set your requirements and your kind of spec around the hardware, and then the whole manufacturing process starts. So it could still be another 3, 4, 6 months before you actually then get product coming off that line. And because, in the case of bike share, hardware goes onto the bike, but then you've got all of the digital component around bike share, in that time where you're kind of working to deliver the hardware, the digital team is still moving forward. These questions don't kind of hold back the digital team. They help the hardware team kind of make decisions quickly and get to the point. So ultimately, we found that it helps us move a little bit faster. Let's take an example of one question that we actually had, just to illustrate why this kind of helps bring these two teams together. We found that the most impactful question and the most difficult one for us to answer at one point was, how well can we enforce the parking of bikes within defined zones? So imagine that on a map, you just kind of draw some geofenced area, and then we want to be able to enforce whether or not bikes are left in those areas, whether they're outside, all that sort of stuff. How do we go about doing that? That's a pretty big, broad question, and you can kind of intrinsically see that the answer to that question might have an impact on hardware. For example, how good are any of the sensors that we put onto our hardware at telling where the bike is? Like, what's the accuracy of them? Can anything be done to improve that? Is that accuracy okay? But this is more a question about, from a business perspective, why do we care about enforcing parking in kind of certain parking zones? And what's the impact on the user if they don't do that? So from a design perspective, what does that whole experience look like for a user? And so these are all very, very much connected. So to answer that question, it's not just like a hardware problem that you have to solve. It's not just electrical engineers who have to answer that. It's not just designers who have to answer that. It's kind of a combination of everyone that has to pitch in and answer that question. So again, that's why we found that kind of this way of thinking much more holistically about what you're doing, answering questions on your roadmap, tends to bring the kind of hardware and software teams together a lot more to think about solving the same sorts of problems. Another quick example that I want to run through is this idea of faking it. This probably draws from Tom's talk quite a lot. Take the example of when we were setting out to build bike share. It was going to be a long time before we actually had bikes on street, right? It was a long time before we had hardware. It was a long time before we had anything that was communicating to our back end. But we had to get to a point pretty quickly where, as a digital team, we were building out infrastructure to communicate with bikes. We were starting to work on mobile apps and understand the experience from the user's perspective. But how do you do that? How do you move forward when you haven't got the hardware yet? If the hardware team is still working on that, well, we faked it. We literally built virtual bikes. So as the digital team, we went away and kind of designed these little black boxes, like virtual black boxes, not physical black boxes. They were completely separate to the hardware team. Like the hardware team weren't writing the code for that. The firmware team weren't writing the code for that. So we built these little boxes that had some input and then kind of behaved in exactly the way we thought a bike was going to behave when we put it onto street. We could even like plot these bikes on a map, and they would start to go for journeys. We could run kind of automated tests, which suddenly spun up loads of bikes and took them for journeys. In this example, in the early days, we actually kind of boxed them into like a 100 by 100 meter square or something, so they will just start bouncing around inside when we spin up tests. But we found that this was incredibly useful in bringing our teams together, because not only does it help the digital team move forward without being blocked by the hardware, but it actually drew alignment between the digital team and the hardware team, because all of a sudden we had this kind of common language in terms of how we were expecting our bikes to behave, how we were expecting our hardware to behave before we had the hardware. And so that was beneficial to the electronic engineers, because they could suddenly say, well, actually, it's not going to be able to do it this way, or maybe we can do it a different way. It also had benefits on the kind of embedded system side, because they were the ones that were ultimately going to be kind of writing the firmware that sits on the hardware to perform exactly the same behavior. So it helps us kind of talk in this common language about what we expect a bike to do and how we expect it to behave. So there are two quick examples of things that we did that we found kind of brought the hardware and software teams a bit closer together. We're by no means doing it perfectly or even necessarily right. Like, I'm sure we'll find a lot of this changes. A few more things that we're really interested to try and figure out how we can do as a hardware business, kind of turning into a kind of overall kind of digital and hardware company. How do we involve the firmware kind of side more in our discovery process? Going back to that first example of having a roadmap of questions, the benefit that we found was that it introduced this element of discovery into hardware that hadn't properly existed in quite the same sense. We kind of shared a bit of discovery between the digital and hardware side, but we could probably do a better job of involving the firmware kind of team into that discovery process as well. The second one, I'm really super interested to figure out if we can introduce a sprint structure to electronics development. I'm not entirely sure how that would work, again, because of the speed, like the speed issue and the dependencies. But if we can figure out ways to kind of almost pull the hardware team along with us as a digital team and get them to move faster, that would be super, super cool. Our electronic engineers are, by and large, involved in our own sprint planning sessions, and they come to all the meetings. They get exposure to what we're working on, but they're not truly embedded into the kind of our sprint structure. And then the third one is, it would be awesome if we could completely unify our backlogs. If as a business and a whole product development team, we could see like what all the different kind of functions are working on, how, like what they've got coming up. We're making a little bit of progress on this. We're big fans of Clubhouse, especially the different projects within Clubhouse. And so you'll see here we've got some projects that are kind of more digital. We've got some projects at the bottom which are kind of more hardware projects. But that's cool because that ultimately means that everything, all these backlogs can work towards the same epics. They can work towards the same milestones. So we're making some progress on that. So I've talked about how our hardware business is kind of bringing digital into that, and kind of some of the lessons that we've managed to learn from each other and how we bring those together. I imagine most people in this room are not working with hardware, so how does this apply to a digital team? It kind of comes back to those two examples. One, I would just force yourselves to really kind of step back and think much more holistically about the product and the service that you're aiming to deliver. Think about that roadmap of questions. We had the benefit in that we kind of almost fell into that because we had to answer some of those questions to solve the hardware, but we found that delivered benefits to the hardware side, but also benefits to the digital side. So I'd encourage you to do that. And the second one was the point about faking it. Similar, again, to Tom's talk, like, it was really beneficial to us to build code, to write code and to kind of build things in the case of the virtual bikes, that we assumed we were going to throw away, like they weren't going to make it into production in any way. But actually, that delivered a lot of value to us and ultimately helped us move faster. So something that we thought we were going to throw away helped us move faster as a team. So when you are kind of milling around later today, when you go to work tomorrow, I guess the one takeaway that I would encourage is think about what is the most important unanswered question that you have that prevents you as a product team from moving forward. And who do you think is involved in answering that question? Thank you very much.